If you enjoy this podcast, then be sure to check out Farm Small, Farm Smart Daily, where you can get your daily dose of farm wisdom. Tune in every day to learn the latest tips, tricks, and stories from the world of farming. Whether you're a seasoned farmer or just getting started, our podcast has something for everyone. Join us as we explore topics like farm business, crop planning, soil management, and tools and technology. Start your day off right with Farm Small, Farm Smart Daily, available on all major podcast platforms. Don't miss out. Subscribe today. And one thing I found really interesting was the paper that you wrote comparing soil test methods. And I found it fascinating because I didn't even realize there was different methods of testing the soil. So can you talk about that paper, why you thought that was important to compare two different soil testing methods and really outline the differences between those two methods and why one might be superior to another?
Absolutely. There are lots of different tests and ways that you can use to measure your soil. A lot of them that are commonly used are pretty strictly chemical or physical in nature by looking at your infiltration or your soil structure, looking at the physical properties, and also to standard soil tests that use different types of harsh acids to extract nutrients and look strictly at the chemical component of your soil, like what is the phosphorus, potassium, magnesium levels in the soil. And experiments for decades have been done to determine, based on these soil test rates and plant uptake rates, like that's what's used to determine fertilizer rates that people get recommended by all sorts of land-grant universities and industrial ag places like that. So there's lots of different ways, and there are different extractants that are used on different soil types. The Malic 1 extractant is used commonly here in South Carolina, and that's what I used in this paper that I'm working on. And that's what we use, all the time. Our land-grant university here uses that. That's where we send our samples to get soil tested, and that's the way that we look at things almost every single time. But what's lacking in those is really any aspect of what is happening biologically in the soil. You can look at soil in a microscope, and there are certain things that are big enough that you can tell what they are. But when it comes down to bacteria, they're so small that it's hard for most, advanced microscopists to be able to tell what these things are or exactly calculate what they're doing or what their function is. And so there are these other kind of soil health tests or biological soil tests that can measure other things that act as a proxy for soil biology. One of them being like the Solvita CO2 burst test, measures 24-hour or 4-day carbon dioxide, which is used to determine the microbial activity in your soil. You dry soil and then you re-wet it to stimulate microbial activity, and you measure how much carbon dioxide those microbes have respired. Because just like us, most of them need oxygen, and then we breathe out carbon dioxide. So do they. So if we quantify how much carbon dioxide is in there, and it's something that you can use comparatively over time, you can see if your microbial activity is increasing or decreasing. And that CO2 burst test is part of the Haney soil health test, which uses a different combination of weak acids that are meant to mimic acids that plant roots use to make nutrients available. And it also looks at the water extractable nutrient content of the soil, which is more representative of what's available to microbes. Because there's nutrients that are locked up in organic matter, that are locked up in parent material like rocks and stuff, that can be broken down and exposed with harsh acids, but they're not in that actual soil ecosystem, aren't really available for anything to use. So part of looking at this test and comparing these two testing methods was to see what's the better way for us to look at it. Are we measuring the right thing by looking at chemicals? Are we measuring the right thing by looking just at the biology? And so looking at the various aspects of these two tests over 3 years here and 6 crop rotations, and we used not only those soil tests, but also the fertilizer recommendations that came from both of those soil tests to see how much fertilizer was really necessary in these systems, and then which of those recommendations were more accurate at predicting a real observable yield that we could actually get in the sandy soils that we were in. If that makes sense.
So if you take a more traditional, I don't want to say traditional, it's the wrong word. I don't know the right word, and you can maybe correct me here. If you do a soil test that's based on this chemical analysis, where we're just going to really test the nitrogen, the phosphorus, the potassium, et cetera, all the little minerals that are in our soil, and we have a regenerative soil, like where we're trying no-till, we're trying cover cropping, Are we potentially getting an inaccurate picture of what's in the soil or what our soil needs?
I would definitely say yes, it's potentially inaccurate, but at the same time, I don't really know what's accurate. And that was part of comparing these two. Like I compared the Haney test that is aimed at a more biological aspect and compared that to the standard one that's focused on chemistry. And they tell me different things, but in looking at these and correlating all these soil test numbers from both soil tests to the yields we got, there was certain times where one test was maybe more accurate in determining fertilizer rates than the other, but the other was better at different yields. Like they both are telling us different things, but it almost led to more questions because neither one was like a magic bullet that was telling us like, oh, this is what I need. There's useful information from both for sure, but it really continues to make me question, like, is the way that we're looking at soils or trying to quantify these things in the soil, are we really looking at it the right way? And at the same time, that's also why I got into the metagenomic study, to start looking directly at the biology to see if that's a better way. And that's going to take some more time and further down the line for me to really better understand that and link that to our not conventional, but our, typical production outcomes and the things that farmers are interested in. But there's just so many different ways we can look at what's in the soil. And it's all useful to some extent, but we can't always do every single soil test and pull it all together. So it's really an experiment of what's going to tell us the most information, what's going to be the most useful. And it's hard for me to say this was better than this based on the information I got, because somewhere the Haney test was accurate at kind of these more feasible yield outcomes that we see in the coastal plains of South Carolina, but the land-grant university that we got the standard soil test from, like the chemistry-based one, was way more accurate at fertilizer recommendations and actual yield outcomes for people who are trying to get that higher end yield.
So if you take the two soil tests that you compared, and they're part of a soil testing toolkit, how many other potential tests are in that toolkit for looking at these types of values around soil? So you looked at two. Are there more in that toolkit?
Yeah, there's a lot more. And we're actually hoping to get funding on a project that's a couple years, 2 or 3 years long, I think. Buzz and I in the soil lab to test more of those on the same lands, to not only test them, but also to use various soil testing methods during the process of transitioning from conventional to regenerative. So not only in a conventional system, which tests are telling us the most useful information, but also in a regenerative, or as you're making that transition, like in a conventional system where it's more focused on tillage and fertilizer inputs, maybe the chemistry-based test is going to give you information that's more useful to that system. But if you're trying to go regenerative, maybe a different test is going to give you more useful information, since you're not looking just at chemistry, you're looking at biology. And so hopefully that the ball gets rolling on that project, and we can really start to see, like, looking at more than just two, what's the best thing to look at on a whole scale of management practices.
So for somebody who's trying to grow regeneratively, you're getting soil tests, they could potentially, not definitely, but potentially be getting a soil test that's a misfit for their farming management system.
I think so, yes. Yeah. You could get a soil test that says you have this much or you don't have this much of a nutrient, say phosphorus, in your soil. But if you have a healthy biological system and lots of hyphal networks that are able to go deeper and beyond your plant roots, they have the capability of pulling that nutrient from other places and giving it to those plant roots. Versus a conventional system may not have that, and you may have to supplement it more because you don't have that kind of scavenging and that partnership that a healthier biological ecosystem would.
So I'm thinking, if I'm a regenerative grower and I'm practicing no-till, I have cover cropping, and we assume that a lot of these things that we've talked about in this interview are happening. You're getting nitrogen, or you're getting nutrient scavenging, you're getting nutrient recycling to some degree in the system because the biology is working. You're adding organic matter, which is stimulating that biology, which is helping us in a lot of ways. It's freeing up nutrients that are locked up in the soil, parent matter, the organic matter, all that type of stuff. Could I make the argument and just say a soil test is just a waste of time and energy if I can't really tell if the information's accurate? Like, it might be useful, it might not be useful.
In this scenario, you're saying we can't quantify what that is, but if you continue to get your soil tests regularly as you are doing these things anyway, you're doing these regenerative practices, That's providing you with the data.
Okay.
So you can see over time, and maybe you can see your farm or your productivity increasing. You can visibly see your soil getting healthier. If the soil test that you're getting is showing no change, then you can probably conclude, yep, this soil test is not telling me anything worthwhile, and maybe try a different one. And I think that if you're in that system and you look at the more biological soil tests that might be more of interest to you, it's looking at water extractable nutrients, more like bioavailable nutrients. I think we don't know exactly what those is. What is the best part of that to use for fertilizer recommendations and stuff? That's something that I'm still questioning. But if you're doing it, I think there's still a huge benefit in getting those soil tests and just looking at that data your own over time. And then if you do that for 5 years and you go back and you look at 5 years of soil test data, maybe you completely ignored all of the fertilizer or whatever recommendations that came with that. That's fine. But if you go back how your productivity was or wasn't over that time, and you go back and look at that soil test, you can probably see what's happening, what is indicating what you saw, or what was a good indicator, what was not. So I think that by doing soil tests, at least annually, if not more, that creates an opportunity for you to quantify what's happening on your system.
Hey there. Want to spend less time pulling weeds? Check out Soil Shield by Modern Grower. It's the pre-cut landscape fabric solution to help you drastically reduce weed pressure. Just roll it out, staple it down, and plant. Then let it do the work for you. Say goodbye to endless weeding and hello to more free time. Plus, it's high quality, durable, and will last for years, saving you time and money in the long run. It's available in a variety of row and hole spacings to accommodate all the crops that vegetable farmers grow. Learn more about Soil Shield landscape fabric at shop.moderngrower.co or using the link below.